Alright, we're going to figure out a formula for the surface area of a cone. And this is pretty cool stuff. It involves a cool trick in the middle. And um, yeah, I think it'll be fun. So here we go. Surface area of a cone. So what we have here is the radius of a cone and then its slant height, which is the distance from a point on that circular base to the apex here. So knowing nothing but the surface or the slant height and the radius of a cone, we'll figure out the formula for the surface area, which is the area of the circular base plus the area of this curved surface. And I kind of think of this as a party hat. I don't know if you've seen those. You know, with the strap on the bottom, you strap it on your chin. They're kind of ridiculous. Okay, right. So party hat. So it's but a party hat with a bottom actually. Okay, so the surface area, let's just call it a let's do a nice color. Okay. Would be all right, so it'd be the area of the circle, which we know. The area of a circle is just pi r squared. S by definition there. Pi r squared. So that's something we already knew. Didn't have to figure out. Okay, plus, and here's the critical part, plus the area of this curved surface that connects the base to the apex. So how are we going to figure that out? Well, what we can do is we can cut it with our minds. Just cut a slit up from the bottom to the apex, and then lay it flat out on a table in our minds. And if this is hard to visualize, and for me it is, this kind of thing is hard to visualize. I would encourage you to either find a party hat and cut it and lay it flat to see that this works, or take a piece of paper and cut out a shape like this, you know, basically a circle with a wedge missing, and then take these two edges here and line them up and tape them together, and you'll see that it forms a cone. Right? So this is what we're doing. We're taking that surface and we're laying it flat so we can figure out what its area is. Alright. Now, this distance here is s, the slant height. So this part here would become this part here. And you'll see that if you use an actual cone and cut it, and if not, just trust me that the slant height translates to the radius of this partial circle here. Okay, so that's s. Now, the area. So if this were just a total, complete circle like this, its area would be easy to figure out, right? The area of a circle is pi r squared. So pi, and then the radius r would actually be s. So this would be pi s squared. That's what it would be. But we don't have a full circle. We have a full circle plus this wedge missing. All right. So how do we figure out what the area of this circle minus a wedge is? Well, let's look at it from the perspective of circumference. You'll see that this distance here corresponds to, I'm going to do this in green, corresponds to the circumference of the base of the cone, right? So this would be, these would have the same lengths, right? So you cut this and then lay it flat. This part of the cone becomes this part of the circle minus a wedge. All right. So what's this distance then? This circumference would be 2 pi r. That's 2 pi times the radius is what circumference is for any given circle. All right. So this distance is 2 pi r. But what would the circumference of the whole circle here be? So we're going back to the white color. Actually, let's make that yellow. Let's make that red. Well, here the radius is s. So 2 pi times the radius would be 2 pi s. So that's the whole kit and caboodle. 2 pi s. So what we've got is a partial circle, a partial circumference, and that is 2 pi r. Right? So this partial distance is 2 pi r, we decided. And it's out of the full circle of 2 pi s. So then we can come up with this sweet ratio, 2 pi r over 2 pi s. So this part out of this whole. 2 pi and 2 pi cancel out. So we've got this ratio, r over s. So now the area of this sector, without this chunk here, would be the the area of the full circle times this ratio. So we're taking the area of that full circle, pi s squared, and we're multiplying this by this ratio. It's like saying, it's like this. Say like this green was only 75% of this full circle. Well, then to find the area of this partial circle, it'd be like saying, well, this area is 75% of the full circle. It's something like that. So we're taking this area of the full circle, pi s squared, and we're multiplying it by this ratio that we figured out, r times s. So this we could rewrite as pi s squared. We could write as pi times s times s. That's a times, and then times r over s. So if we do s in the denominator here and s up here, one set of these would cancel out. So this area would be pi s r, or I don't know, to make it alphabetical, pi r s. Okay, so that's the area of this partial. Actually, this would be called a disk. The circle itself is just this outside rim, and then this sector would be the part of the full disk. So the area basically of this curved surface would be pi rs. So coming back up here, so we have pi r squared would be the area of the circle, and then plus pi r s. So the surface area of a cone is pi r squared plus pi r times the slant height.